Today we're going to be looking at using a plugin for Grasshopper in Rhino called Ladybug. And Ladybug is now part of a larger suite of tools known as Pollination. And Pollination's really a conglomerate of what used to be Ladybug, Honeybee, Dragonfly. I think there's another one in there. Essentially, it was used for environmental analysis, things like weather and climate, things like that. And then also building analysis so that you could have validated numbers for things like LEED accreditation or green building. But for the sake of this video, we're just going to be looking at the Ladybug portion of this. And what Ladybug is really good at is early schematic design. So before we really know what our building looks like and where the windows are, we were just looking at some basic outside factors. It's also good to generate some easy visuals to better understand the climate that you're designing in. Best way to get Ladybug as of today is go to pollination.solutions/rhino-plugin. You'll click on the download latest version, and it'll ask you to either sign up and create a new account or sign in if you already have an account. Once you do that, it'll show a plugin page, and you'll click on the download Grasshopper version. This has pretty much packaged all of the tools that previously you would have to download and then unpack and unblock and then load into your specials folder within Grasshopper, and is a lengthy installation process into a very nice installer. So I strongly recommend you go this way instead of the food for Rhino method of installation. So you'll download this, it'll download an exe file, you'll run that, and it'll install it into Grasshopper and Rhino. After that, you'll open up Rhino and you'll open up Grasshopper. And to open up Grasshopper in your standard tab, there's a little green button, and you can type in Grasshopper into the command line. Both will get you to the same place. And that will open up your Grasshopper canvas. And I'm going to expand this so that it's a little bit easier to see. I have quite a few plugins already installed. So we're going to click on Ladybug tab, because that's the tool we're going to be going over. And at first, it might seem a little bit daunting. There are a lot of different tools within this add-in or plugin. And the way to think about it is really you kind of read it from left to right, top to bottom, and it'll get you most of the places that you need to go. So the way to start this is we'll go to Ladybug download weather, and we'll drop that node in. And it's going to ask us for a weather URL. And optionally, it says an optional file path where everything will be downloaded and unzipped. We're not going to worry about that right now. This would be more if you wanted to have everything saved on your local machine rather than kind of streaming it in. So if we go and we'll click on the second one down, Ladybug EPW map, what this is going to ask for is a true or false input. So we can do that with a few ways, but I'm going to use a button. And for those of you who are unfamiliar with a button, I'll just open up a panel by clicking / in the canvas, and I'll pipe that in. And so if I hover over the button, nothing's happening. But if I click the button, it says true. So I just want it to fire off true for me. So I'll bring that in. And I'll click the button one time, and it'll open up in your browser a really nice EPW map. So all of these little dots are data points that we can use in Ladybug. Because I'm in the United States, we're going to use that. And specifically, we're at Montana State University. So I'll click on this one. It'll tell me where the data set is from, a few of the different designations for this data set, and I can either download data from it or I can copy the URL to my clipboard, and it should say copy to clipboard in the lower left hand corner. I'll jump back into Rhino, and I will make a panel that has this information. And this might be a little bit too long, so I'm just going to rearrange this, bring that into my weather URL. And now now it's pretty much giving me my EPW file on the fly. So the next thing I'm going to need to do is import EPW. And it seems a little bit redundant with this, but it actually, if you break down what each of these nodes is doing, it makes a lot of sense. So the top one is finding what information you need. You're then copying that down into a URL, which is where it exists on the internet. This one is actually downloading it and holding it in essentially like a temp file, unless you specify a folder. And then from there, you're extracting that EPW and you're downloading it into Ladybug. And we can see we get a whole bunch of really useful information coming out of that EPW. We have temperature, humidity, wind speed and direction, things like that. So the next tab in Ladybug is Analyze Data. And we're actually going to skip over that for now. There's a little bit more in there than what I think we need to go over now. To do this relatively fast, we'll just do Ladybug hourly plot. And we will say for our data, we don't need location data because that's already built into the EPW. Let's say we want to look at dry bulb temperature. So if I come over into this perspective, it is a little easier to see in a top view. I can see a really nice chart of the time of day and the days of the year and what the temperature was in a easy to read visual with a nice legend already built in. If we want to start to change some of that, we have all of that available to us over here. So we can change that legend. If we want it to look different, what we could do is we need a legend parameter. And that's, we just double click and we'll say LB legend parameter. We can say LB legend parameters. And this gives us a lot of different things that we want to change. You have full customization of what this legend is showing you. But if we bring that up into our legend parameters, and let's say we just want to change the color, we want this to be graphic. That LB legend parameters is found in the extra tab. We can go to LB color range. And sorry, this might be opposite of what I was just saying on you work left to right. Your extra tab kind of holds stuff that isn't part of asking Ladybug to do an analysis. The extra tab is stuff that things like changing colors, making it look different, having your views set up. So we'll bring our colors in, and by default we have our regular colors. And if we hover over the index input of that, here from this index, it's just asking for a number. So I will make a number slider between 1 and, or 0, 0, and 29. And I'll pipe that in, leave it at the default. So one way to get to kind of get that information in, and we can pipe this into multiple places. So we might save this up in the top for now. Maybe I want to do another analysis of the relative humidity as well. So I can just bring that right down in here. Maybe I'll disconnect these just so things are a little bit more clear. So now they're plotting over top of one another, and I don't like that. So what I want to do is I want to set where this data is located, and that's what this base point input is. So I'll come over to my parameters tab, I'll make a point container, and I'll right click on that point container and say set one point. I'm going to bring this kind of over to the right. I'll bring that in for my base point. I'm just going to copy it down, and I'll bring that in for the base point on this side. And because I have the gumball enabled, I can just drag that up. And now I have a really nice stack with very similar coordinates. And I can see already that there's an interesting correlation for this location between the humidity and the temperature. So I see that the humidity is very low when it's very hot. So it's a very dry, hot summer in August. I can also see that in the winter, when it's starting to get really cold in December and January and February, is that my humidity is quite high comparatively. So we have humid, freezing cold temperatures and very dry, hot temperatures. And that's something that may be useful to document and to have in the back of your mind as you're starting to go through your designs. Let's just add one more for fun. We will add the maybe barometric pressure in. Again, I'll click on this point and I will drag that up, starting to create a better visual understanding of this weather data very easily. We'll do another flavor. I'm going to jump back over into Ladybug and we'll do a monthly chart, which is quite nice as well. And let's grab the monthly chart for temperature. So bring that into my data. And then I also want to grab a base point. And for this base point, I want to move it over. This is another flavor of visualizing this information, but we can see on that temperature how much that fluctuates throughout the year. And we can see the minimum and the maximum, and then the mean or the median in between for each one of these months. We do get some kind of chopping in between these, and that's just the result of this data. That's what we have no control over that. But it does give us a nice, and sometimes in July or in August, it gets all the way up to, 34 degrees Celsius. And then in February, it gets all the way down to negative 19 degrees Celsius, which is a pretty huge swing there. So we could go through and do another one of the monthly charts for each one of these. And it really is about what you think is the most useful for what you're doing. Again, we can change the legends, we can change colors, we can change all of the graphics for this information and export it to whatever visual or platform you want to look at. So after we have all of this information, and I'm just going to group it and drag it down for a little bit. Now we've looked at the Visualize Data tab. Next, we want to be able to analyze geometry. In order to visualize data, you don't always have to analyze data, but there are components in here that you'll need to use to get over to this other side. So under Visualize Data, we're going to look at the Ladybug sun path. We're going to make a sun path. And it's first going to ask us for where north is. We're just going to use the default. We're going to assume north is on the Y direction. So north is kind of up in plan. And we will bring in our location. And if we zoom out a little bit, we'll be able to see that now we have a sun path based on this location. The next thing that we're going to need in this is called an HOYs as a list, or HOY. And essentially it's another acronym. I believe it stands for like hours of a year. Could be wrong on that. We'll go to Analyze Data now. And we'll say Ladybug calculate HOY. And the reason why I've been jumping around like this and kind of going forward and move backwards is that's really the way that I use this tool the most, is if I go to Analyze Geometry and I click on one of these, it's going to give me a whole bunch of inputs, and not all of these inputs are going to be default Grasshopper tools. A lot of them are actually going to be something from the step further back. So similar thing with HOYs is I was able to go to the Analyze tab, and I can see Calculate HOY. Go through the Analyze tab, just read through these very briefly. You don't have to commit all of them to memory by any means, but just get a little bit familiar, and then it'll help for the next step. So the early ones, we didn't need to go backwards at all for the early visualized tools that we were looking at over here. But as we get further down, it starts to get a little bit more complicated. Here we have HOY, and we can plug that into HOY. And we haven't set any of this, so it's all using default, which essentially sets the sun like right in the middle, dead of noon in the middle of the year. But we want to have control over it. So if we hover over the month, it's asking us for a number between 1 and 12. So let's make a number slider between 1 and 12. But now I can see as I change my month where that point is moving. And maybe to make this a little bit easier to visualize, I can come out here to my sun points. And that's what this point is referring to. And I'm just going to make a simple mesh sphere, because meshes are a little bit lighter than surfaces. I'll use that as my base. A little easier to understand visually. And as I move that from month 3 to month 4 to month 5 to month 6, we can see how that sun moves around the sky at the same day and the same hour and the same minute. So the only variable we're here is changing month. The next one that I want to change is, let's say, day. So we'll go, is asking for an integer between 1 and 31. So we'll make another number slider between 1 and 31. And we'll plug that in. And now, as we start to move the day, we can see that we have a little bit more fine-grained movement in between each one of these numbers. So a pretty high degree of variability. We could also then specify our hours between 0 and 23. So I'll make another number slider between 0 and 23, and we have our hour, and now our sun's gone. Well, that's because our hour is at hour 0, which is midnight or 1 o'clock. So as we start to move that around, we get to maybe 5 a.m., 6 a.m., we start to see the sun, 7, 8, 9, and we can start to see how the sun moves around the sky in that arc throughout a given day in a given month, which is pretty useful. So, we can change and slide each one of these around. In the Analyze Geometry tab now, I want to see the sun hours for an object. And the output of the sun path is a vector, so I can do that. And I can also, vector, and I can say vector display. And if I plug that vector in for there, and I plug the some points in for the anchor, and then the vector in for the vector, I can see which direction that's pointing. I can also go to vector EX, and this will allow me to change a few of the other things. So the point is going to be the sun point. The vector is going to be the vector. The other thing I can do is say amplitude, and I will change my vector, and then I'll copy this, and I'll say my amplitude is going to be quite large. I have to plug this into my vector. So there's my amplitude, there's my vector for the point in the sun. Just playing around with some display options for how to visualize what that sun is doing and what that vector input is going to do for our analysis. So I'll just move this over here. Again, when we come back, we can still play with this, and we'll see where the sun, well, that's the month. So I want to change actually the hour, and we can start to see what the direction and the vector input is for that. And vectors are not dependent on geometry. They're pretty much just there's the data. If we look at the output, it's defining a angle, azimuth, and pretty much a horizon or altitude for what we would need to calculate where the sun is at. Whew. All right, so little side note there. Got off on a little bit of a tangent. So the next thing we're going to look through here is we want to just get this to start running. So we want to be able to analyze geometry. That's where we found this on the Ladybug. We're analyzing geometry. So we're going to need some geometry to play around with. So I'm going to make a very rudimentary amount of geometry. I'm going to start with a ground plane. And I'm just going to drag that out to be pretty close. And then I'm just going to make a series of kind of dumb little boxes. They're not dumb, they're just boxes. And we'll drag a few of these out. Maybe this one will be kind of relatively tall. And I'll make another little guy over here. And maybe one more tiny pole over here. And we'll just kind of move those around. Nothing spectacular about this. I'm just trying to get some information together to show for the analysis. We'll do one more over here, just for fun. Just for fun. Okay. Great. So now I need to reference that geometry into Grasshopper. So I'm going to use just the geometry container. If I come over to parameters, I could define it as a curve or a plane or a surface, and all of that's fine, but the geometry container is going to work because I don't believe that Ladybug cares what flavor of geometry it is. It just wants to know that there's some geometry. So I'll select the base plane, I'll right click on the geometry container, the black hexagon, and I'll say set one geometry. So now I have that referenced in. And I'm going to make another geometry container, and I just type geometry by double clicking on the canvas, and then I will reference in the rest of the boxes. And for this one I'm going to do it a different way, so I'll say set multiple geometries. Because I don't have anything selected, then I will select the boxes that I have, and I will either right click or hit enter. And so now I can plug in my geometry. And if I hover over any one of these, it'll give me hints of what I need to find. But for the geometry, this is the stuff that I'm going to be analyzing. And for the context, this is the stuff that is going to be essentially casting a shadow for this analysis. I might just move these back a little bit since I'm going to be able to see those shadows a little bit better. I'm just going to move these back a little bit. There we go. And now I need two more inputs to get this to work. I need a grid size, which is pretty much the opposite of your, if you think about like a resolution, your grid size is setting the resolution, but it works opposite of like a computer monitor or a TV, where the higher the pixel count on a TV is, the higher the resolution. It actually works the opposite for this tool because it's referring to the size. So the smaller the number, the tinier the pixel, and the more pixels you'll have. Just kind of a base explanation there. I'm just going to make a slider between 1 and 10. And I'll probably start with 10, just so it's a little bit more coarse. And then offset distance, I don't need to worry about. It's essentially the offset of the analysis from your analysis geometry. The legend, I'm not going to change what the legend is yet. And then CPU count, this will let you throttle up or down the how much of your computer processing, your CPU, your computer processing unit is going to be using. And then run is going to tell it to actually do stuff. So I'm going to make a Boolean toggle instead of the Boolean button, because this time if I click it to true, I want it to remain true. This is kind of like a turn it off, turn it back on thing, rather than our button we did in the beginning where it's like, I want you to fire off a true for me. So now if I click this on to true, it's going to run. And we can see where our angle is and how that vector is affecting our shadow. And there's some glitching happening because we have geometry in the same plane, because both of these are visible. So I'm going to hit Control and the spacebar and hide this. And this makes a little bit more sense of how that is working. And because I'm only using a single point of a single hour and a single day, and really it's a snapshot in time is what I'm giving it, is that it's just going to say it's either in shadow or it's not. There's really no way around that. But I can also come back here and I can go to my hour and start to move that around, and I'll see how that shadow is starting to affect the ground. So hopefully this makes a little bit more sense in that. But let's say I want to do an analysis over the course of a total year. I don't want to just look at a tiny snapshot and point. I want to look at kind of an aggregate of information. So rather than feeding this a single month, what I can do is I'm going to feed it multiple months. So I can either make a list of numbers that are all those months and drop all of those in there. One way to do that is with a series, or I could come into a panel, I can right click on that panel and say set multi-line data, and then I can say 0, 1, 2, 3, 4, and I think they said there's no 0, so I can do it this way, and then bring this into my month, and now I'm looking at multiple months. And if I start to change that time, right, we can see where those months are and how each of those are affecting our analysis. So I could continue on the line and say, 5, 6, 7, 8, 9, 10, so on and so forth. And I'll see the rest of those vectors. And now I can start to see that there's a variation between that shadow. I'm seeing a gradient starting to arise. So let's get a little bit crazy with that. Let's make a series. And we're going to bring in all of, we're going to start with our first one. We're going to leave our step at 1 of things we want. We're going to bring that last one in. We're going to bring that into our month. So now we're hitting all 12 months. But I want every hour of the day. So I'm going to say, and I actually should have maybe started with the opposite of this, but it's all right. We're looking at months in the year instead of hours in the day. And now we're going to be looking at both. So we'll slide this one back. We're going to start our count at 0, and we're going to set our count at 23. And we'll bring that into our hours parameter. And so now we're starting to get a little bit more accumulation of information. But as we look at our vectors, I can tell something's wrong. That's not all of the hours everywhere. And if I look back at my series, these are like flattened. So I actually want to graft these so that it's looking at all of the hours within each of the months. And if we think back to the beginning of what we were doing with data sets, that should hopefully make sense. If there's a list and the branches, if I hover over this now, I can see I have branches for each one of those indices, and then it'll apply this list to each one of those branches. Go back and look at my data sets conversation about it if that's still confusing, or let me know if you want me to go back over it. So now we have a pretty cool looking visual to me. I don't know if I need to look at these vectors anymore. They might be a little bit much. So I'm just going to group these, bring them up into my no man's land, and hide all of them. Or maybe I'll just disable them. Disable. Great. So now I can start to see from the top, which is probably the better view to look at a flat plane of the ground, where I'm getting more or less sun and shadow throughout an analysis period. We could make this a little bit bigger to push our legend out, or we could even hide our sun path if we didn't want to see that. I find it useful to leave the sun path on because it gives me a little bit of a visual to understand this stuff a little bit better. So from here, let's say I didn't like these colors. Let's say I wanted them to be more black and white. Well, we'll go up and we'll grab our legend parameters and our color range and our number slider that we had from before when we were playing around with the visualized data in Ladybug. And we'll bring that parameter into our legend parameters. And now we can see we get a little bit different color gradient. If I hover over this, and I look for something that I think is a little bit better for amount of sun and shadow, right right, number 5 is shadow studies. So if I type in 5, we'll see what that gets us. I like that. And we can look back at that in perspective. Pretty cool. If I change my legend, or sorry, if I change my grid size to a lower number, like number 5, we can see I get a lot more fine grain information in here, which is quite nice. Now, this isn't anything, I guess, too crazy right now, but this might be helpful to, like, if your client's looking at a house over here and they're like, we love natural sunlight, you might want to let them know that maybe they shouldn't buy that piece of property, or vice versa. I don't know. I'm just making up scenarios of where you might use this in the real world. But let's say this is my design, and I don't just want to look at the ground plane. I also want to look at what my design is doing to, let's say there's a series of buildings here, or it's a sculpture. Anyway, let's say I want to actually be looking at these objects. Well, they can be my context, and they can also be my geometry. So I can add it into both, and then it will calculate everything. So I still have my ground calculations, but now I also have all of my surfaces are also calculating where there's sun and shadow. And where this can be useful is, let's say I move this like very close up here. It's going to update, and we can start to see the shadow line of that building being closer. And maybe I move this one further back. And it starts to pull out some of that information. We could go even finer grain with that analysis. We can see the shadow lines off of this corner. We can change our analysis grid to be even tighter together and get even more accurate data. But every time you change that grid size, you're going to be increasing your calculation. And so from a very basic level, we have a little bit more intuitive way of understanding and designing. And rather than just using some shader or a viewport or something that's going to, that looks good like this, we're actually using physical data that, this is based on the environment that this project is built within, which is a much more powerful way to do it. And to me, it creates the way I like to think about it, it's like a little bit of a feedback loop in the computer with a connection to nature. So like the natural forces are actually being explained to me while I'm designing. I think that's kind of poetic or is cool to think about. Anyway, so with that, we've been able to visualize stuff. Now let's do one more analyzed geometry. Let's look at incident radiation. And we're going to go through this in a similar way. And to make this a little bit more clear, what I'm probably going to do is I'm just going to group all of these. And I'm also going to turn them off, because we're going to do another little bit of a problem solving working backwards way. So for radiation, it's going to be asking us for what's called a sky matrix, which is a little bit different than their sun area. So again, we're in analyzed geometry. If I jump one back, I'm like, where do I find the sky matrix? And I click on here and I start looking, I'll find a sky matrix. I'm going to use a cumulative sky matrix for this one. And then I can plug that into the sky matrix, and I have that working. But I also need a location. So I'll bring that from our, from our very first EPW that it contains it. Bring these a little closer together. And it's going to ask me for some more information. So I'm going to grab the HOY section, because I saw it needs that as well. Why did it just tell me that's old? It's funny. All right, we'll grab a new one of those. We'll say Ladybug calculate HOY, and I'm going to enable these. If I hold Control and Spacebar, get up my little Hot Wheel here, and I'm going to, maybe I'll use the same one. So hour, day, month, day, hour. It's going to take a little bit while it's thinking. And I'll bring that into the HOY. So those are the ones we've gone over already. But if I look, it's also looking for, and I accidentally plugged my location into north. Interesting thing about the sky matrix is that we're going to leave north at the same place. So we don't disconnect that. We're going to use our location. But now it needs a little bit more information. It needs the radiation for those. And if we look in that EPW file that we got in the very beginning, we have radiation. So if I look at direct normal radiation, I'll plug that into direct radiation. And then below that I have diffuse horizontal radiation. I'll plug that into diffuse. And now my sky matrix is working. A few more inputs than just the solar study. Then what we'll look at is we have to do a similar thing here. We need context, we need geometry, and so I will steal out a few of these, pretty much the same parts and pieces that we used from earlier. And make sure they're enabled. So I'll bring that in for my geometry, and I'll bring in the base plane. Then I'll bring in the boxes for my context. And then I'll bring in my grid size into the grid size. And then I'll click on run. To true, it'll take a little bit of time, and then it'll give me my incident radiation. And this is a little different than our shade and shadow, as we can see, but it essentially is relating to how much or kilowatt hours per meter squared of direct radiation or incident radiation we're getting for a place. This can be really useful if you're thinking about like ground cover. A asphalt road is going to absorb a lot more heat and be hotter for like your thermal comfort than, let's say, a field of grass. And then it could be useful if you're thinking about like if you're doing a passive solar design from a very kind of coarse grain scale here. Similarly, we're going to add in the buildings to our geometry. We'll wait for that to load. And now we can see where that radiation is hitting on our buildings and how that's working. And again, it's a little bit different than just the shade and shadow, and it's giving us some different outputs here, which is pretty cool, I think. Maybe you're looking at solar potential or something like that. Same thing, we can change the kind of inputs and go on from there, but very similar to our upper example. And maybe we want to change the legend for this one as well. So I'll just copy that out of here. And I will enable them. And I'll bring that up and I'll put that into my legend parameter. And instead of the shade and shadow study, I want this to be radiation. And so I might use number 3 for Ecotect, because I like Ecotect colors. And I'll wait for that to kick over. And this makes a pretty nice visual that's easy to understand of where incident radiation for your project. So again, the fun part is we can move this stuff around. If you see little elements like this, these are artifacts because our grid size is too large. So if we want those to go away, what we can do is change our grid size. And I'm going to go down to a 2. It'll take a little bit. It's going to take a lot longer than a 5. The grid size computation time, it's based on like a square and not linear. So if it's a 10, if you go down to a size 1, it's not going to take 10 times longer. It's going to be like 100 times longer. Okay, so that's finished, and we have a pretty interesting solar radiation modeling environment. We can move these elements around, start to see how our design is being affected by natural forces. So a pretty cool way to look at things. And with that, again, let me know in the comments if you have any questions, if there's anything that isn't making sense here. I'm happy to do that. And then also let me know if you want me to go over any more of these tools. If we want to look at wind roses and some of these other analyzed geometry elements, I'm happy to do that. But for now, I think this video is good at just showing you the basics and getting you started. Okay, so a couple of things that I want to do now is just to show how I might use this if I was to start a design and where this would be maybe a little bit more useful. So the first thing that I would do is I'd make a scribble, and I would label these blocks so I know what's going on, and I'll call this sun shadow study. Get rid of that. Maybe I'll group all these together. And I'll hold Control G to make a group. I'm going to do the same thing here. I'm going to say this one is, I want to make a scribble. And I'm going to call this radiation study. And I will group these. And I could do some better grouping as well. Like really, I would take my HOYs and group that. And now I know that this is kind of its own function here. And maybe my legend stuff and group that. And then I'll group it all together. And now I have some nice like working environment here. Keeping things more organized is going to help a ton so that you're not just constantly dealing with massive amounts of spaghetti. So we could bring all this stuff around or not. So now that I have all of this going on, let's say I want to start to change my design, and I'm going to actually scope this way up to 10 so it runs a lot faster for me. And let's say I want this to actually be like a roof. So I can come in here and I'm going to drag it around. And now I can start to see how that starts to affect my design. Maybe I want to scale this down a lot, make it a tiny little guy. And now I can start to see how that starts to affect my design. So some fun things to play around with that. Maybe this roof actually is over here. And I put this little kind of tiny guy up over in the corner for a support. And now I can start to see how that, of course, everything's flying. Maybe that's the way it works. Everything's using maglev technology. But again, just to showcase how this could be a little bit more useful, but also wanted to show that grouping your objects and what you're using in the end will give you a much easier use of Ladybug. So we could call this visualize. I kind of leave it in this little bit of the same category as the way they come in. So all of this is on my import. This is my import section. And that's my first tab. I guess this would technically be on my second for analyze. Then I have visualize. So I don't know, maybe that's a flawed logic, but organize it any way you want. But just biggest thing is to keep it clean and make sure that you understand what's going on. I could enable my sun and shadow study, make sure that my geometry containers have the right information in them, and move on with that. So fun stuff there. And let me know in the comments if you want me to go over any more of these tabs. Under Analyze Geometry, we can look at wind roses and views and sky matrices and things like that. Human to sky relation. All of this stuff is a lot of fun to play with. I just wanted to give everybody the general building blocks to start to make stuff for themselves. And again, any one of this stuff, if you're curious about it and you're getting stuck, or you just want me to make the video about it, let me know. Hopefully you find this to be a useful tool and it's fun for you to play around with.